Okay, back with example 4, it says Serena drove 54 miles in the city, averaging 24 miles per gallon. Then she drove 251 miles on highways. For the entire 305 miles, she averaged 30 miles per gallon. What was her average fuel consumption rate on highways in miles per gallon? So let's go back and see what we have. So she drove 54 miles in the city, averaging 24 miles per gallon. So if you think about this, she's driving in the city. Then she drove 251 miles on the highways. So that means like the interstates. For the entire 305 miles, she averaged 30 miles per gallon. So for the entire trip. So if you think about when you travel, you will travel roads in the cities, and then you're going to travel roads in the highways. So that would be equivalent to the entire trip, would be city plus highways. So let's write that down. City plus highway is equal to our entire trip. So now let's go pull what we know based off of what the word problem told us. So in the city, she drove 54 miles, averaging 24 miles per gallon. So 54 miles at 24 miles per gallon. Okay. And then it says she drove 251 miles on the highway, but it did not tell us what she averaged on the highway because that's what we're looking for. What was her average fuel consumption on the highway? So we're going to call that X miles per gallon. And that's going to be equal to the entire trip, and it tells us the entire trip was 305 miles at 30 miles per gallon. So now let's set up our equation without all of the units. So you have 54 over 24 plus 251 over x equals 305 over 30. Now I could convert these to decimals, but it's going to be easier to just practice what we've already learned with our least common denominator. So I'm going to say, just come to the side. So remember we need one of each. So we need 24x and 30. So if I compare this to our least common denominator, I'm going to need a 30x, top and bottom. Here I would need 24 times a 30. And here I would need a 24x. So again, there's different ways to solve this equation. We're trying to practice what we've already learned. Now that all of our denominators are the same, I'm going to circle the top. So here I'm going to have 30 times 54 for 1,620x plus 180,720 equals, and I'm just multiplying these, 7,320x. So then we're going to solve this equation. So when we subtract those, we're going to get 5,700x. We'll divide. And we're going to get x equals 31.705 miles per gallon. So again, the question asks for her average fuel consumption on the highways. If you go back to how we set this up, X does represent miles per gallon on the highway. So you know you've answered the correct question. Okay, so our last example, a little bit different. So it says, how much pure acid must be added to 50 milliliters of 35% acid solution to produce a 75% acid solution? So we're going to add, we know that, and how much pure acid, there's our question, and then of in math means multiply. So the first thing I'm going to do is I'm going to take that 50 and I'm going to multiply by 0.35, which is at 35%, and that's going to give us 17.5 milliliters of acid. If it's asking us how much pure acid, let's let this be called X, okay? So let X equal our pure acid. So again, you've figured out that it's 17.5 milliliters of acid out of the 50 milliliters. So we're going to set up that fraction. And then we're going to add some amount, top and bottom, and we want it to equal a 75% solution. So I changed that to a decimal as well. I'm going to put this over 1 for a fraction, and then I'm going to cross multiply since it's a proportion. So 1 times this will be 17.5 plus X, and then we're going to have that 0.75 times 50 plus X. So 17.5 plus X equals, we're going to distribute here. So this is going to give us 37.5 plus 0.75x when you distribute across. Then we want to solve for x, so I'm going to subtract 0.75x. Then I'm going to subtract that 17.5. So we'll get 0.25x equals 20. We'll then divide by the 0.25. And you're going to find out that x equals 80 milliliters of pure acid. And again, we let X represent the pure acid, so you're finished with the problem.